are already familiar with finding the area of a rectangle by calculating the length times the width of that rectangle. For our lesson today, we're going to talk about length and width in terms of being a base of the shape and the height of the shape. So for this rectangle, I'm going to call this the base. It doesn't matter what side I call the base of a rectangle, but for this case, I'm going to do it at the bottom. The height of a shape of a rectangle is the perpendicular distance from top to bottom, from top to base. So it will be the distance that is perpendicular to the base. And that would be my height. So my formula we'll be using today for area is area equaling base times height. Now we are going to look at this parallelogram. Remember that parallelograms have two sets of parallel sides. So we have our parallel sides running this way and our parallel sides running that way. So when I am trying to derive the area formula for a parallelogram, and by derive I mean figure it out and prove it, what I can do is look at my parallelogram and notice, this piece right here seems like it can fit in right over here. So I pre-cut mine already, but you can go ahead and cut yours and move this in to this spot right here. Now, this is a very familiar shape. It's a rectangle again. Notice I haven't gotten rid of any of the pieces of the shape, so it's maintaining that same area. And now this shape has its base and its height, its perpendicular distance from top to bottom. So, if I were to move that back, it's the same shape. And now I know that I can calculate the area of a parallelogram the same way as I would a rectangle by taking the base times the height. So I'm going to write, base times height. Let's look at this long, skinny parallelogram. When I want to find the area of this, I need to assign one of the sides as a base. And before I do that, I think, maybe I should move this piece around and make it simpler for myself to assign a base. So now I'm going to say, all right, this is my base right here. And my height is going to be that perpendicular distance to the opposite side. So once again, proving that the area of a parallelogram is the base times its height. Now we're going to look at a triangle. So looking at this, I notice that there's 3 sides, just like all other triangles, but there's not much to chop up to make a nice parallelogram or a rectangle for myself. So what I'm going to do to prove that this triangle has an area formula is I'm going to take a duplicate, the same exact triangle, and I am going to fit it so that it creates a parallelogram. Now we already know that an area of a parallelogram is the base times the height. So, looking at this parallelogram, I have two pieces, each as an equal triangle. When I'm finding the area of a triangle, I really want to know what the area of half of this parallelogram is. By assigning this a base and this as my height, because this is the perpendicular distance up to the top, I can say that I am looking for half of a parallelogram. So my area of a triangle is going to be 1/2 of our magic word of being multiplication, the base times height. Taking a look at another triangle, we're going to do the same thing. I'm going to take my identical triangle. I'm going to fit it in to make myself a nice parallelogram. I'm now going to assign a base and a height. So I like to do the bottom base, whoops, and then making my height. And since I want half of that parallelogram, I'm taking half of the base times the height. Now let's take a look at a trapezoid. This is going to be our most involved area formula, but it's not very hard once we look at it as a picture and map it out. So the things that we know about a trapezoid is that there are two bases. We would call these two different bases, and they're both going to be of different lengths. So there's base number 1, and here's base number 2. I'm going to go over that again with the blue so it stands out more. That's a little better. All right. Now, I can't chop anything up on this because it will not make a perfect parallelogram. So again, I'm going to have to take an identical trapezoid. Before I start maneuvering it around, I'm going to mark my same bases with the same colors. So I have my shorter base, I'm going to keep that as my pink. And I have my blue base as my larger one. And I'm going to label this base 1, base 1, base 2, base 2. Alrighty. So now that I am ready and labeled, I'm going to maneuver this around and make my parallelogram, because we are super comfortable with parallelograms at this point. If I can just get it lined up. All right. So, looking at what we have here, notice my base has changed a bit. the length of my base includes the length of base 1 plus base 2. So my base is base 1 plus base 2. The height of my parallelogram is still the same. It still goes from this bottom perpendicularly to the top. And that is my height. I'm going to draw another height over here just for our diagram's sake. And just like that triangle, I am trying to find half of this parallelogram with a trapezoid. So my area formula is normally that base times height, right? For that parallelogram. But what I'm looking for is half of the base, which is the two bases added together, times that height. And there you have it. The area formula for a trapezoid is half of the sum of the two bases times the height. Now that we've derived these formulas, let's put them into action. So we are going to find the areas of these two parallelograms. So remembering that the area of a parallelogram is base times height. For parallelogram number 1, I want to look and see, okay, in this example, what did they decide was the base? And they decided that this top line was the base. And we'll label that as base. Sorry for the shaking. I'm getting used to this camera arm. And remember that height is the perpendicular distance from the base to its opposite side. And that's our height. So, the area, we know, is equal to base times height. If you don't know what that dot means, that's another symbol for multiplication. You might see it on certain documents and items. I might use it interchangeably with the X. But since we're dealing with some letters and whatnot, I figured we'd use our dot. So I rewrote my formula, and now I know what the base times the height will be because I have a base length and a height length. So now I'm going to fill in those values. My area is equal to 10 times 4. And I know that 10 times 4 is equal to 40. The unit I will use is centimeters squared. I will do that because when I multiplied these two together, I also multiplied their units together. And centimeters times centimeters equals centimeters squared. Looking at this next example, I'm looking for a base and a height again. Notice here they assigned the base to be on this side, the skinny side, and that's totally fine. We're going to label that as our base. And here we have our height, that perpendicular distance, and they show us there's a right angle. They're showing us that right angle. The perpendicular distance from the base to the top. I'll label that height. Again, I'm going to rewrite my formula. Area equals base times height. The reason why I rewrite the formula is so that when they become more involved for myself, I don't miss any pieces. So I have my area equaling 5 times 7. And that means my area is 35. And my unit, since I'm multiplying centimeters times centimeters, will be centimeters squared. Now let's look at some triangles. Remember that the area of a triangle is calculated by taking 1/2 of the base times the height. So let's look at this first example right here. I'm going to move my camera in a little bit. And I'm going to notice, again, I'm working with this camera. It's not really working with me. I am going to figure out what have they determined as the base. In this example, they give us this labeled side of the triangle. So they're taking that as the base. So I'm going to highlight that for myself. And I am going to label it base. They also give me this height right here, that perpendicular distance from the top of the shape, which is the vertex most opposite the base. And that distance is 5 meters. So I'm going to write that that's the height. Rewriting my formula, I have the area of a triangle is equal to 1/2 times base times height. I'm going to fill in my numbers. I have my area equaling 1/2 times 14 times 5. And you can approach this a few different ways. So because it's a string of multiplication, you can multiply them in any order due to order of operations, and we do not have to do something in a particular order. What I like to do is I like to take half of whatever this number is, whatever my base is. So I'm going to rewrite my area of my triangle being 1/2 of 14, which is 7, times 5, because I brought that guy down and the answer to this down. Now I can solve that. Area of this triangle is equal to 35. And because of those units that I'm multiplying together, my unit will be meters squared. let's look at this next triangle here. Notice that this is a right triangle, and right triangles have a right angle in them. We know that already. Now, when we are talking about right triangles, it may seem like there's not really a height. There's no perpendicular distance between the top and the bottom, but really that distance is going to be one of the sides. So we do have a height and a base. In a right triangle, these can be interchangeable, meaning that I could say that this was the base and this is the height, or that this is the base and this is the height, because it's still a perpendicular distance. For our ease, I'm going to stick with this bottom being my base and this being my height. Rewrite my formula. Area equaling 1/2 times the base times the height. Filling in my numbers. Area equaling 1/2 times 8 times 4. Taking this, taking half of 8 and doing area equals 4 times 4. And area equals 16. And my unit, since I'm multiplying 2 centimeters together, is centimeters squared. Let's take a look at this funky, obtuse triangle. It seems like there's something a little weird going on, but we can manage it. So, we notice that they are showing us a base here, and they're showing us the height on the outside of the triangle, over here. It doesn't really matter where the height is located on the triangle, as long as it's showing that perpendicular distance from the base to the topmost part of the triangle that is perpendicular to it, which is this vertex right here. So I'm going to call this my base and this my height. Rewrite my formula. Area equals 1/2 times base times height. Fill in my numbers. I have area equals 1/2 times 9 times 10. Since this isn't a nice even number that I'll split in half, we are just going to jump down, and let's do these two numbers first. We'll bring down our half, and we'll take half of 9 times 10, which is 90. Much simpler to do, no fractions involved in my answer, no multiplying of fractions. Half of 90 is 45. Looking at those units, I'm multiplying 2 meters together, 2 meter values together, so it's going to be meters squared. Last but certainly not least, we are going to look at the areas of trapezoids, the formula, and how exactly to use that funky looking formula. So, remember, my area of a trapezoid is 1/2 of the sum of the two bases times the height. So, looking at this, they gave us some information. They showed us the lengths of the two bases. and they showed us a height. It doesn't matter exactly which base you call base 1 or base 2, but I like doing my bottom longest one. Sometimes it's not the bottom, sometimes it's the top, but I like to do my longer one as base 1 and my smaller one as base 2, just for simplicity. And that this right here, the perpendicular distance between the base and the top being my height. So now, rewriting that formula down here, the area of a trapezoid is 1/2 of the sum of base 1 and base 2 times the height. I'm going to plug in my numbers and chug. I have my area equals 1/2 times 6 plus 5 times 2. So we need to follow some order of operations. If you're not familiar with order of operations, here's a brief tutorial. Order of operations follows PEMDAS, meaning we solve our parentheses first, then our exponents, then multiplication and division starting from left to right, and addition and subtraction starting from left to right. So, in this case, I need to first solve what's inside of my parentheses if I'm following order of operations. So my area is equal, still bringing down this 1/2 because I haven't used it yet, times this added up, which is 11, times 2. Remembering from earlier, not a nice even number to split in half, and I'm not feeling like dealing with an extra fraction. So I'm going to multiply these two together, and I'm going to take 1/2 of 11 times 2, which is 22. And then 1/2 of 22 is 11. And my unit, it seems like it would be centimeters cubed, but it's still going to be squared. So I'm still going to call this centimeters squared. All right. Now, looking at this one right here. In the review topics, you might have stumbled across a trapezoid like this. We call this a right trapezoid. Right trapezoids have a right angle, and that's really all there is to it. They contain a right angle, but only one, because if they included another, it would be a rectangle. So, looking at this, I still recognize my two bases, the two lines that are parallel to each other. My longer one being base 1, my shorter one being base 2. And I have a height because it's still that perpendicular distance between the bases. That is still my height, even though it's not in the middle like that one was. This is still a height. All right, rewriting our formula. Area equals 1/2 times the sum of base 1 plus base 2 times the height. Fill in the blanks. area equals 1/2 times 9 plus 7 times 5. All right, solve my parentheses first because order of operation rules. We have our area equaling 1/2 of 9 plus 7, which is 16, times 5. Since this is a nice even number, like we've talked about previously, I can take that, split it in half beautifully, and I get area equaling 8 times 5. And the area of this trapezoid is 40, looking at those units, centimeters squared.